Hello viewers, this is Dr. Rana and today I am going to explain you the second 2D problem, which is actually a time dependent problem using COMSOL. The problem is actually on the heat transfer. So heat conduction equation we are going to use on the solid. So I'll quickly start with the COMSOL and the model wizard. Two-dimensional geometry I am going to take. So options are many more. You can just go for the heat transfer in solid. There is options are there. Just pick this heat transfer in solids. Yes, add this study. So with time dependent study today I am going to discuss. So press done. So you are added the study and your equations is being imported to the console. Now you can give the specification of your material and modeling part and even the boundary conditions. So this is your geometry and you can just construct the geometry first. So method is simple, just go to this geometry. I wish to use everything in centimeters, so I can write here in centimeter. Default may be the meter, it's hardly matters. I can use center at 0 0. So build it. So now the meter is very small, no problem, you can just click it. This. So another I wish to use is a circle. Is basically the hole in the on the plate. So I'll make this as a 2 centimeter. To make it in the center you just go for 0 0. So it's very easy here in the console, and this is center. So what do you wish to? You wish to use the boolean. Either you go here, the option is here also. You can use the differences. So first is this one screen and then you wish to subtract this one screen. So build. So this is now your model. So now second thing, you can add the material. I wish to add iron. You can search here, even you can go if you know the place where it is been. You can see that iron is here. You just add to the component. So iron is being added to there. The properties are here. If you wish to change some properties and you think that some properties are not correct, you can change it yourself. Otherwise you have to choose all domain. So the color of this domain is now will change. So it's obvious that iron, this is now made up of iron. So next thing is your model, your specification of this. Now you can go for the model. This is okay, just go for the solid one. You can change the heat conduction because I can make it user defined. If I use it as a constant, you can take 1 2 3 as per your convenience. Otherwise you can use it from material, so it will automatically take as a default values. So initial values you can choose. I'll take initially this as a 100 degree, sorry, 100 Kelvin. So next, the thermal insulation, all are thermally insulated. So I wish to add the temperature values. So I can give these two edges as a temperature of the same 100 Kelvin. Now I can add also the heat flux equation. So for the heat flux I'll use this edge as a heat flux. So this is, and this one remains as such, you can say that thermally insulated. So for the next I can include the more heat flux equation. So all these are containing some kind of material or fluid. You can give the convective heat transfer, and H you can give the standard as a 5, and temperature you wish to use is a the cold fluid. You can use a 0 Kelvin, or for instance 5 Kelvin. Now I'll quickly go to the mesh. So you can use the physics dominated mesh, and if I wish the solution for directly, I can compute this. You can see that the solution is being computed. So this one is the output. So I have used the very less frames. So if I go one by one, you can say this one temperature, then go for this one, the temperatures go on increasing. If I go back and I can wish to increase the frames like 100 range, time range I wish to increase, you can compute it again. Yeah, output is there for this frames, and you can see that there is several time steps you generally choose, and you can see easily that how the temperature is being changed from 0 to this is the 0th time level. When the initial boundary condition is interrupted, you can just see the results is this. As you go on changing the time, the results become this. But you wish to create an animation for this. The very simple command here is available is animation. The player, you have to click it. Now the animation for this is being generated. It may take a time. You have to be patient, because otherwise if your configuration of system is very large, then it's okay. Now you can see your animation. This is the animation for the 25 basically frames are used. You can use a repeat. No need to increase the frames because sufficient, 25 is sufficient. Just play it again. Yeah. So this is actually how the heat is transferred. Practically you can see that everything is of 100 degree, and this temperature is go on increasing. Reason being, this is actually the cold region and this is all are the hot, and you see that this is your temperature. You can stop it. If you wish to see the contour isotherms, you can see that contour isotherms. Yeah, this is your contour isotherms. But if you wish to generate the player, you just again write the player. You can see that how the therms are generated. Got this. How the temperature. Maybe this problem is I have taken random boundary conditions. When you go for any practical situation, you will get very good results using COMSOL. So that's very interesting. You can even export these results for the publication, and you can use the different models for this. This is the actually capturing of one study. So I'll stop it at this. You can see that even the convergence plot is there. This I just rename it is my first study, and you can see that the linear study. Now I wish to include or change the model. I wish to go to the solids and wish to make this K as a user defined. So I can able to write T by this 200 this. Now this is actually a user defined and become a nonlinear problem. And now I back to here, I can rename this as a nonlinear. Okay. Then go for this and compute it again. Now the system become nonlinear, and obviously it will take a time. So I have to wait for the output. So I will make K as a user defined. so you get output. So similarly you can make a player animation. Now the animation is treated as animation 3. Here data is automatically being saved one by one. So if you wish to see all the animations, it will be listed here in this. You can check the animations here. Animation 1, you can even export the animation, which will I discuss later on. So just press it and you can run this animation. So now the temperature is changed, so the results is somehow different. This is enough, and so I'll in the next lecture I'll explain you the more complex geometry even for the 3D and other bugging errors in the console. So till then, have a good day.